What is radiation? Most people think radiation is something that gives superpowers, like Superman, or cool mutations like Godzilla, or think that only nuclear bombs give off radiation. This video's goal is to teach you all about radiation. Can you see it? Can you touch it? Is it all around you? Is it dangerous for you? Where does it come from? My name is Jose Abram, and I will make sure you know all about radiation. To understand radiation, we need to know what the electromagnetic spectrum is. But what does electromagnetic mean? The electromagnetic spectrum occurs in an electromagnetic field, which is a combination of two fields. The first one is an electric field that describes the region around the charged particle, and anything that enters the region receives a force. The second is a magnetic field, which is a region around a moving electric charge, which is acted upon by the force of magnetism. Now, the electromagnetic spectrum is the range of frequencies of EM radiation and their respective wavelengths. There are 7 types of electromagnetic waves, all of which exert radiation. They go from biggest wavelength to the smallest wavelength. They are radio, micro, infrared, visible, ultraviolet, X-ray, and gamma ray. The electromagnetic spectrum divides radiation into 2: ionizing radiation and non-ionizing radiation. It divides them to denote the danger and energy of the radiation. Ionizing radiation is radiation with so much energy that it strips the electrons from an atom. It occurs in waves and particles. Ionizing radiation is so dangerous to humans because when atoms of cells become ionized, 3 things can happen to a cell. It can die, it can repair itself, or it will mutate incorrectly, which is where the cancer comes from. The first example of ionizing radiation is alpha particles. These particles are emitted from the nucleus of radioactive atoms. Alpha particles have the least amount of energy and are stopped by paper and skin. Their speed is low and are most harmful when they come from inside the body. The second example is beta particles. These particles are ejected from the nuclei of radioactive atoms. Their energy is greater than alpha, but less than gamma. These particles are stopped by aluminum or wood. Their speed is fast and are most harmful when their source is outside the body. The last type is gamma radiation, which is electromagnetic photons emitted from the nucleus of radioactive atoms. Their speed and energy is colossal, which is why they require extensive shielding. For example, several meters of concrete or several centimeters of lead, a very strong element. To demonstrate ionizing radiation, 3 objects will be dropped on different materials to represent what each radiation is stopped by. Non-ionizing radiation does not have enough energy to strip electrons from the atoms. It does not penetrate deep enough in the skin, but it can be a risk to the eyes and, if prolonged exposure occurs, to the skin. In this demonstration, what is happening is that the oven is heating up. As things heat up, they exert more radiation. The heat makes atoms move faster, and it warms our food. The following equation was created by Stefan Boltzmann. It describes the power radiated from a black body in terms of its temperature. P means the energy radiated. A is the area of the emitting body. T is the absolute temperature in Kelvin. The second symbol, called sigma, is the Stefan Boltzmann constant, and the other Greek symbol is called epsilon, which is the emissivity of the material. Humans are most exposed to radiation when they go to the hospital and get medical treatment. Now I expect you to have learned what radiation is. In conclusion, radiation is really a double-edged sword. It can kill us, but it can also cure us. Radiation is all around us, and it is a very important subject that people don't really understand.